Today, I'm going to talk you how in Node.js took 10 years, actually 14 years, to get protected from a very, very nasty DDoS attack. The thing is that if you are evil enough, your best weapon might be slowness. Don't you believe me? Bear with me. First of all, I would like to introduce myself. I am Paolo. I'm a staff DX engineer at NearForm and also NodeConf member. I come from this little tiny piece in Italy that I challenge everybody which is Italian here to name the region. They pretend we just don't exist. But yet somehow Near found me and shipped me here, and I was introduced by James, which was a wonderful honor, which is amazing to me. Anyway, let's get started. Now, what we use every day? We have seen in this wonderful conference that we use a lot of application. We basically use it for everything. It comes from fun activities like social networks, streaming services, everything you can think about, right? But it also comes to mission-critical systems like banking, telemedicine, security system, and some might argue that even social networks now come to mission-critical, which, again, I don't agree, but that's fine. Somebody, they think about it. Now, the problem is that web applications now play a very, very important aspect of our lives. And there are companies which very, very smart and good people like Nick, who Ron spoke about yesterday, that kept us safe, exposing all the security things we are facing into. Unfortunately, there are way more people, bad people, even smarter than what people are usually, that think about how can then mess with our application, which is a problem because this application must not go down. They cannot go down because it will be a mess. And the problem is that we are all vulnerable. Nobody is safe. And let me just give this straight to you, folks. You cannot control everything. That's impossible in general life, in all matters of life, and even more in IT security. You just can't control everything. Which comes to this little thing that people have built, which are denial of service attack. This is a kind of attack in which a network resource is made maliciously unavailable to all intended users. Usually, the most common one is the distributed denial of service, which I will just call it DDOS, where the incoming traffic comes from a lot of places across the globe, which makes mitigating most difficult, as we will see in the future. It's a common belief that usually DDoS attack require and use a lot of resources, which makes them slightly less feasible for attackers because they are expensive, and harder to mitigate for people because, once again, it's expensive to mitigate the network. You must have balancer and so forth. Now, I make just one question. Do you think that it's actually still true? Well, let me introduce you the real enemy for today, which is this little guy. Now, I'm thinking about actually renaming this talk and just simplify to taming SlowLoris in Node.js because what it's all about. I mean, I gave a fancy long title. I might rename it because it's more appropriate for this kind of topic. Anyway, the SlowLoris attack. The idea is actually surprisingly simple and surprisingly very, very dangerous. The SlowLoris attack was DDoS attack created by Robert Hansen, Snake, in 2009, which basically aims to bring a system down by using the minimal bandwidth possible, close to nothing, basically, as we will see in a few minutes. As you can see behind me, the idea is that you flood, like in a regular DDoS attack, your server from various resources. Now, another fun fact about this attack is that if you search it online, you will just find that SlowLoris exists only for HTTP. But as we will see in a few seconds, it's not only HTTP. Anything that is connection-based, and surprisingly, I was also told that it also applies actually to UDP in some cases, can be targeted by this kind of attack. It's just a matter of understanding your protocol and adapting it, which is very, very dangerous. Let's start easy. Normal server activity. What happens? A client connects to your server will establish a connection, send the request, complete the request, wait for the response, disconnect. I'm slightly simplifying the analysis, ignoring things like HTTP pipelining and HTTP klive on purpose, because the general idea is that they make one-to-end request, and eventually, at some point, a reasonable point in time, they just disconnect. To simplify, let's say they make one single request, they go away. That's the first client. Each client, when connected to the socket, to the server, will create a socket, and retaining this socket for the client allocates a certain amount of resources, especially RAM, on the system. That's it. Then the client disconnects, another client arrives. Yet, to our server, there is only one client connected, right? It sends the request, completes the request, waits for the response, goes away. That's it. Fine. And then we have the third one. The idea is that over the course of the time, the amount of resources consumed on the server is relatively stable because the number of clients stays on an average. Of course, there are bursts, but they are limited in time, and they're not that great usually. And basically, the server can handle all the incoming traffic. The important point here that people don't usually realize because they don't work on low level is that retaining a socket, if your server is badly designed, can be a huge problem because you must handle a socket in 3 levels. First of all, you have the operating system level. Just keeping the socket, the ports, and everything set up, in case of TCP, a lot of protocol overhead and so forth, is expensive, takes a certain amount of RAM and other resources, CPU scheduling and stuff like that. Then each socket, especially on Unix system, is backed by a file descriptor. And this file descriptor is available to the process. Each process has a specific limit on file descriptor and a specific limit also on the operating system itself. The entire system can manage a certain amount of file descriptor. I hope that none of you buy the news that when you set ulimit infinite, you actually get infinite number of file descriptor, but that's not even possible, right? You should know that. Finally, there is the application overhead. I mean, application in this case, let's think about Node, but it can be Apache, Nginx, they all look the same. Application also must manage high-level operation on the socket. In other words, nobody's here want to use a select in C like we did in the 90s. We want to use just receive on event emitter and so forth. So additional overhead on the socket, for the socket. Which brings us on how SlowLoris attack works. On the image there, you notice the subtle difference. There is no green line anymore. Why? Because basically each client establishes a connection to the server, starts sending the request, and first of all, the speed rate is very, very slow. And I'm talking like 1 byte every 5 minutes, 1 byte every 15 minutes, literally 1 byte, and so forth. Moreover, it never gets to the ending point. The attack will be successful much earlier in the past. Why is that? Because it sends the request, and actually I'm even simplifying here, the one client only sends one request. Of course, one client sends multiple requests in different sockets, right? So, connects, never disconnects. Then we get a second client bombarding with even more requests. And the server usage keeps increasing. It's a monotonic function that keeps increasing over time. And of course, as you might guess, we get to the final point where the server has exhausted its resources and cannot accept any new socket. Therefore, the service is interrupted. It's simply interrupted. We cannot accept anything. They were successful. Now, how do we stop it? First of all, foremost, I'm a Node core member. I should not say that, but actually it's the brutal truth. Never put Node.js as a point of contact towards your clients. Period. That's it. Don't do that. Why? Because we keep using nodes as, the HTTP server node is very fast, right? The I/O is very fast. Yes, it's true, but actually Node is a general purpose tool. It's a runtime, so it could be used for anything. So you can't simply do that. Why? Because it must solve a lot of issues. We have seen in the talk yesterday from Daniel that there are thousands of pull requests, thousands of releases, and so forth. So we can't really target all the vulnerabilities in HTTP. Which brings to the second point. Software like Nginx, HAProxy, and all API gateways, if you like, anything you can use in front of that, are more suited for this kind of problem. They solve this specific problem. Let's say HAProxy cares about the net layer, doesn't care about the crypto layer, just to say, we'll make an example, right? So we can assume they are better suited for this kind of problem, so just use them. Then, if you can't, there are some mitigation strategies you can implement on your software if you wish. And this brings to another problem in the DDoS attack. Distinguish between attacking clients and clients which happen to be on slow network, faulty networks, unreliable networks, mobile networks, just come from a decent network but with a huge round trip because they are on the opposite side of the globe and you're not using a CDN, so you're already a bad person anyway. That's another point. But it's hard to distinguish whether they're just attacking us or they just happen to be slow. And unfortunately, none of the strategy I will mention today is 100% effective. The point here is that know your application. We always usually care about, you know your customer, KYC, right? Also KYA, know your application, because you know if your application should wait for 15 seconds for a request to be completed or 99% of your requests finish within 500 milliseconds, so you can cut out clients much earlier, to make an example, right? So it's up to you. Anyway, there are two strategies that we can use to fight this problem. First of all, foremost, the simplest and also the most effective in the short term is limit the number of connection per IP, rate the number of requests, limit the number of requests per IP. Of course, this is the simplest one, right? But you might also, of course, think that this is a DDoS attack. That's useless. In the short term, it might mitigate the problem. On the long term, it's completely useless because the attacker will just spawn another cluster somewhere else in the world, right? Not going to help. The second one, which is more effective and is actually implemented everywhere, is enforce speed or time constraint. They are equivalent. Usually, the time constraint is implemented because it's easier to manage rather than measuring the network transfer speed. The problem, which I brought earlier, is that it's hard to establish whether you're cutting out a legit client or not. You will lose legit clients and then will complain, send tickets at 2 a.m. in the morning. I mean, we know what happens, but there's nothing we can do about it. I'm a NodeConf member, so what about Node, obviously, right? You're just expecting that. What is about Node? Well, first problem in Node, we have been unprotected at all for 10 years. As you remember, the SlowLoris attack was made in 2009, and the fix was made on the first partial fix was made in Node 10 at the end of 2018, so almost 9 years to be protected partially from this fix. There are two problems with that. As you can see behind me, the API was named HTTP Server Headers Timeout. Why is that? Because, as you know, or might know, Node.js does not parse request bodies. Those ones are delegated to the client. Sorry, to the application, client in that sense, to the application. They never consume request body, and the application is responsible for parsing, consuming, validating, and protecting the bodies. And that's why the fix was partial and not effective. As the only partial protection we had back then, but it was completely partial, is that the http.server.timeout, which is the time a socket can be completely idle before getting rejected, was set by default to 2 minutes, which means that the socket must at least send a single byte every 2 minutes, which kind of mitigated pretty much nothing, the problem. Now, of course, you might think that going over time, the situation would improve, right? Actually, it went worse. There was a request on Node 13, almost a year later, where the API I just mentioned, http.server.timeout, was actually disabled by default. Why is that? Because that's when the serverless environment came out. And basically, they were asking, I leave a long living connection. How can I do that? So we disabled the socket by default. So from that point in time, an attacker could just open a socket and don't send even a single byte. That's it. Just stay there. Open a socket and don't send even a single byte. That's it. Unfortunately, there were needs for that, and we were trusting that, first of all, frameworks were actually implementing body mitigation, and that HAProxy or Nginx were put in front. Talking about the most known application, only Fastify and API implemented a fix for this problem, for the body parsing, which brought us to 1 year later, which was HTTP server request timeout, which of course, as you might imagine, is the timeout, is the time the entire request has before killing out from the server. And it was available on all active Node.js lines. But it was disabled by default. Why is that? Because it was released on Node 14.11, which means a somewhere minor change. We could not enable by default because it would be a somewhere breaking change, so which was like we opt in and we disabled by default, unfortunately. Also, the other problem is that we also chose to disable by default also for another reason. Something that you don't know about and you should know about, and please be careful when you do that setting timers on Node, it's expensive. You recklessly use set timeout, set interval, and all other stuff, right? But every time you add a timeout, you allocate a lot of resources, and you're slowing down the performance a bit. Of course, there are reasons to do that. I'm not saying don't do that, but try not to be evil. At least that's all I ask. Or at least not to be evil and then file pull request and expect us to fix that, at least. Be reasonable. But other than that, the problem was that was expensive, so we chose to disable by default and let the user opt in for that. That was it. And after request timeout was introduced, Node.js had a way to be protected by the SlowLoris attack, not with the default values, but with some intervention by the user, which brings to the next question. Are we safe now? Well, if you have tracked the time, you might realize that I'm still early for me to finish, so of course the answer is no, I have to go on, unfortunately. So the answer is yes, almost. Why is that? The countermeasures were loose. First of all, as I said, we are protected by SlowLoris on Node 16 and below only if you do not use the default values. That's for granted. Second of all, since the implementation was worrying about performance, the performance were prioritized when implementing the fix. And this introduced a very subtle flaw in the implementation, which nobody noticed because it was a very tiny piece in the huge HTTP Node, source code in Node, that whether a socket has timed out would only have been checked after receiving new data. As you might imagine, if the intention of the attacker is to delay transferring the next byte of data to the most possible time point in future, and you wait to receive the next byte to check if the socket has gone timeout, it's useless. Let's say if I delay the next byte by 5 minutes and you wait for me for 5 minutes to check if I should have been terminated 5 minutes ago, makes no sense, right? This was a very subtle problem in the implementation because you are literally thinking about one line of code, which brought to this problem. But anyway, first of all, how do we protect Node.js 16 and below? As I said earlier, don't use the defaults, simply put, don't use the defaults, and make sure that HTTP server.timeout is greater than 0. So you do not let the attacker stay idle sending nothing. That's the first. Second, set request timeout greater than 0 as well. So you limit the maximum time for the client to arrive. Optional but useful in order so you can catch it earlier. Third one, have a lower timeout for the header. So header's timeout should be lower than the request timeout. Warning, Node 16 will not validate for that, so beware. And make sure that basically the request timeout can be used to detect earlier if headers are arriving too slowly, even before coming to the body. And this will cut people off. That's it. So this is a short gist on how to protect Node 16. Memorize these numbers now because they will come later. I will tell you why in a bit. So anyway, you create a server with the usual server. I'm omitting the listener there because, you know. And then you set, let's say, our good defaults are 2 minutes for the timeout, for the socket timeout, 5 minutes for the request timeout, which is plenty of time with modern connection, and just 1 minute for the request, for the headers, sorry. And that's it, pretty much it. Now, all the issues above have been resolved by Node 18. First of all, these defaults that I showed you earlier, these values are actually the defaults in Node 18 by default. You don't have to do anything else. Second of all, there is a new API which is called connections checking interval, which handles timeout in a completely different way. Rather than having a timeout per each socket, we have one timeout for all the sockets in Node.js, all of them, which actually is not a timeout, it's an interval. So every 30 seconds, by default, is configurable, obviously. Every 30 seconds, we go across all the connections still pending in Node, which are still either sending a request, only on the request phase, not the response one, or they exhausted sending a request, they got a response, they are in keep alive, and they are not sending anything. We check all of them, and if they have timeout, we cut them off, replying with 408. That's it. Fun fact, implementing this way of timeout, so one timeout for all the sockets and so forth, also gave us 2% improvement. We were not looking for because we were prioritizing security in this case, but we got 2%. We're not going to throw it away. That's it. The only sad news here is that, unfortunately, this is a firmware major breaking change, so this will not land on Node 16. Now, given that 18 is going LTS in a couple of weeks, doesn't really matter, so please update to 18 as early as possible. Which brings us to the next point. We finally made it. We're protected, that's it. Nothing else to say. We're done. Well, yes, we are done. We are now protected, but there are some things that we will learn from this journey, right? First of all, Lyrath will love this thing. Will come here and say, yes, 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 please. Security, always, foremost, first. If you have time, you can think about performance, but be secure first, please, right? The thing is that when implementing new features or editing previous features, updating them, and anything else, always think about security first, because bad things can happen. I have stories about Italian welfare system that you will love, so do that. Second of all, sacrifice performance. We all know that Node is incredibly fast. We love their performance. When I send a PR, I'm terrified that benchmark will say that I made it slower because I have to rework it. Yes, that's true, but sometimes you have to forget about it. Security first, performance later. And third, and something that people never do, we all know that temporary in IT means forever and all the other stories that we tell each other in these days, right? You have to always validate what you do. Even if his code was written by somebody else 5 years ago, and in case of Node, I tell you that it happens usually because it's an 10 years old code base now, validate what you see. Nothing is set on the stone, because very hidden flaws or code that was not a problem back then, but in conjunction with other things became a problem 10 years later, validate everything you see. Which brings me to the one last thing, very simple. Never assume that the obvious is true. Or, in other words, use common sense, always. We would be surprised how much common sense is underestimated and skipped in daily life. I'm not just talking about IT. Everything is completely ignored. Double check every time. It won't hurt. Eventually, you will be a little slower, but on the long run, it will pay off. So double check all you do. One last mention about my wonderful company, NearForm. Simply put, I don't want to brag, but we have 1 billion uploads on NPM. We have 80% on NPM, so your odds to use NPM packages without incurring in our stuff is low, unfortunately. I don't want to hide on that. We are 300 and counting now, and we are always looking for new talents. Remember, they found me out of nowhere and shipped me here like a package. So we are looking for new talents. We are waiting for you. So if you're interested, you can reach out to all the people outside. And if you have questions, you can reach out to me outside. You can find me on Twitter or GitHub, as I showed you in the first slide. And I think that's all I have for today. Thank you very much.